Alright, so let's finish up this lecture, this one last video in this one series of videos for lecture 5a by looking at an abstract class example. So this is an example of an abstract class. You have one method, print, which is abstract, doesn't have a method body, and so as a result this entire class has to be abstract, even though it has two other methods. Well, actually one method and one constructor, which is a special method. These are methods with method bodies, but if you just have one method without a method body, the entire class has to be abstract. Okay, I hope that makes sense. So we had an example that we looked at much earlier at the beginning of this this lecture, this series of videos. We looked at the circle class and the rectangle, which both derived from the shape class. I've set up this example. Make sure you have access to this, because what I've done is I've said that I made all of the data members private. So in circle, of course, radius was private before, now it's private. In shape, perimeter and area were private. Let me just double check that. Where's shape? Here's the old one. Perimeter and area were private. I keep them private. The one big thing that I've changed is that in rectangle, this new version of this inheritance scheme, in rectangle, if you remember, the length and the width were protected. Why was that? Because I was thinking I would use it in the square class, which extends rectangle. The square extends rectangle, and so I thought I would need this to be protected, but it turns out everything works even if you do make it private. And how do you do that? You use, for example, if you look at the square, it just uses the constructor super to make to initialize the data member's length and width. So by calling the constructor super in square, square extends rectangle. So if you go to rectangle, it has a constructor that expects a length and a width. I call this constructor with the same value for each, the length and the width, and thereby I initialize both the length and the width to the size of the square. Okay, so you can do that. So I take that initial design of this inheritance scheme, I change it by making this private. I also set up, I believe I set up two string methods for all of the classes, so that when you run it, it gives you these nice descriptions. Shape S just has area and perimeter. Circle C has radius, area and perimeter, area of a circle, and then perimeter or all circumference. That's what you usually call perimeter of a circle. And then the rectangle has length, width, area, which should make sense, and perimeter. Same thing for a square. For a square, you initialize the size of the square to be 100, and both the length and the width are set to the same value. So the area and perimeter should make sense. Okay. Alright, so that was one refinement that I made to the classes. And then what I finally did was I set up a version 3 where I used abstract classes. So let me just close all of these and show you version 3 where I made, well, actually one abstract class. Shape is now an abstract class. So the reason we did that was perimeter and area should be defined by the subclasses. That is, if you have a circle, you want to have perimeter and area be like 2 pi r or pi r squared. Right? And then for a square, for a rectangle, the perimeter should just be 2 times the length plus width. Area is just length times width. Now it turns out you can inherit these in square. So if you look at square, you don't even need to redefine the perimeter and the width. The functions that you set up in the superclass, that is rectangle, work just fine for square. So definitely this is one example that you should look at. One big difference is that you cannot have shape be instantiated. Shape is abstract, you cannot instantiate shape anymore, so shape S is equal to new shape is not allowed anymore. You can still create circle, rectangle, square, and all that. And you could also say shape C is equal to new circle, and shape R is equal to new rectangle, and shape SQ is equal to new square. All of those are also fine. Okay, so that's polymorphism along with abstract classes. Later on, we'll see how interfaces work. A class that contains only abstract methods is also referred to as an interface. So it has only abstract methods and constants. So it sort of has data members, but they're all public, they're all final, and they're all static. So the data members, a class it's actually not a class. I hesitate to say it. It's like a class, but in Java, it's called an interface. C# has it. C++ does not have it. So next semester, we'll be looking at C++, which has multiple inheritance. You can have one class extend multiple classes in C++. In Java, you do not have multiple inheritance, you only have single inheritance, but this is a limited form of multiple inheritance because in Java, each class can extend only one class, but it can implement many interfaces. So it's one way of Java having some limited form of multiple inheritance. What are interfaces? Once again, it's like a class, it's not exactly a class. It contains only abstract methods and constants. To be able to handle a variety of events and for a lot of flexibility, Java allows a class to implement more than one interface, and that's about as close as we can get to multiple inheritance in Java. And these are two examples. Action listener is an interface I'm guessing everyone's used. We need this to respond to button clicks or for a lot of user interfaces, text fields. As soon as the user hits the text field and starts typing in something and hits return, we can trigger the action perform method. We can also respond to the user minimizing a window or closing it completely, iconifying it, and so on, using the window listener interface. Two very useful interface definitions. Okay, another way to relate two classes is through composition. What does that mean? That's just an object or a data member in the class that's actually not just ints, floats, doubles, but an object. It's like string. If you declare a data member that's a string, you're using composition. You have a string object, quote unquote, inside this other object that you're setting up. So one or more members of a class are objects of another class type. That's composition. And this is also referred to as has a relation between classes. So that is, if you have a class person info, then you can say that every person in the info for every person has a date of birth object. Every person info object has a person object, which is the name of the person. Okay, so that's in addition to inheritance, you also have composition. We'll get into the differences between inheritance and composition. A lot of times when people see the ability to use inheritance, people will use inheritance, but turns out for many things, for many reasons, for most things that you'll set up, if you can do things with composition, do it. Inheritance is often it's not the only way to solve problems. Often you can solve problems with just using composition. It's a lot simpler. You just create data members that are of certain object, certain class type. Very simple idea, very useful. sometimes better than inheritance. So having gone through all these nice features of inheritance, it's good to take a look at this idea of composition, because sometimes inheritance is not what you want to use. If you see a situation where you use inheritance and you get in problems, you might want to consider composition. Okay.